The Solar Podcast is brought to you by Continental Energy Solutions. I'm Tim Montague, your host. Today, we continue our series on single-axis trackers. They have taken the solar industry by storm pretty much in the last couple of years. Here we are in 2021. And my guest today is a company that has moved from one industry, the auto industry, into solar tracking. And that guest is Ryan Kiarsis. He does business development for Axsus Solar. Welcome to the show, Ryan.
Thanks, Tim. It's good to be here.
I can't remember exactly how we got connected, but I was pleased to learn about your product, and we're gonna give our listeners some really great detail on the Axsus Solar Tracker and your other racking products. Because trackers are so important now in the industry, in the community solar and the utility scale solar industries, I consider it my job to know what is what, who is who. And, there is a pecking order. We have two very big dogs in the US in the tracking space with Nextracker and Array Technologies. And then PV Hardware is a global third with a Spanish product, which has very little footprint for the most part in the United States. And then companies like FlexRack that have been on the show. And I think after our listeners learn more about Axsus, that they will consider bringing you into the fold. And we certainly have kicked the tires. Your pricing is very competitive, and I think it's a very competitive product. So let's first give our listeners some background on yourself. How did you get into the solar industry?
Well, that's a great question. I actually was originally in the home building industry years ago. And of course, that 2000 here in the United States, that took a bit of a downturn. Got a call from a gentleman who owned a solar company, mostly residential. And I didn't know anything about solar at the time. Did I know really what I was getting myself into? But here we are, almost years later, with Axsus in the utility scale market. So most of my experience in the previous line residential market.
How long have you been with Axsus?
I've been with Axsus since July of 2020 and was hired as a business development manager. And I oversee several states, one that you're in, to help to develop product and business.
And give us some background on Axsus and Magna.
Sure. Well, Magna's been around for a while. If you're up in the Northeast, Michigan, you definitely know who Magna is. Where Magna is an automotive manufacturer based out of Toronto. Magna has about 159,000 employees around the world, manufacturing facilities on 4 different continents. They manufacture every component that you can imagine in a car. In fact, they're the only manufacturer that can manufacture a car from the wheels up. If you're driving a BMW in Europe, it was actually probably built in a Magna manufacturing plant itself. So, a lot of it is engineering that they do for folks like Ford, Ferrari, a lot of the things that your vehicle that you probably use every day and don't even think about are products that were developed by Magna, such as the transmission for Ferrari. That if you're Ferrari, the new Ferrari, that might be a Magna transmission. If you drive a Dodge Grand Caravan, the Stow and Go seating, that was developed by Magna. So a lot of things like that we have actually engineered for the companies like Ford and Chevy and others.
And then Axsus, how long has the Axsus brand been on the market?
So, yeah, thanks for asking. In 2008, Magna got into the solar industry. They're headquartered in the Toronto market Ontario area. And in 2008, at that time, there was the utility companies were offering some really incredible feed-in tariffs, you might say, for solar. And so Axsus got into utility scale solar at that point in time. And being the local company, they actually, and being site there, they received the lion's share of the business for them. And so things grew from there. In 2017, we introduced our single axis tracker at SPI in Las Vegas. Overall, as far as installations go, we have about 2.9 gigawatts of installation of solar in the ground around the most of it in the Northwest, some in Europe, and as well as here in Arizona.
Wonderful. Well, I'm going to put some slides on screen, and so our YouTube viewers can really see hands-on what your products are. And we're this opening slide obviously is your fixed tilt products. What would you like us to know about your fixed tilt products?
Well, it's a robust. We offer a variety of options, be it single post, dual post. We can go 4 in landscape, up to 3 in portrait. So we can engineer things to site specific depending on what the project requirements are. So everything can be customized to what your needs are. We also do offer foundation solutions. So if you're looking for a foundation solution, Axsus can help you with that as well when it comes to the fixed tilt racking. Obviously, there's some advantages to fixed tilt racking, that we learned. You look at it, it's usually it's rolled formed components. Things that can be put together with small hand tools, be it a wrench from the local hardware store, ratchet set from the local hardware store. And so, and carrying over from the fixed tilt racking to the tracker, we wanted to take some of those lessons that you might say that we learned from fixed tilt racking into our SolX single axis tracker. So some of those things, if you go to the next slide there, I think it's the next slide, there's some of those lessons would be that, one, as I mentioned, they're lightweight roll form components. 2, you can pretty much design fixed tilt racking to all different types of weather conditions. So we needed a product that would be able to handle, slow snow loads. If you need something that can handle the snow of Canada, fixed or for a single axis tracker, we can do that. The thing is the fixed tilt racking, you can pretty much that almost as it follows a natural terrain. There's definitely some advantages to that. So how we wanted to take that as well and incorporate that advantage into our racking as well. So you think about terrain, that's becoming more and more of an issue in the market these days. As land becomes less available, all the good land is disappearing. All the land that's square, and so we're finding more and more folks are coming across projects that are challenging and they're with grading. In fact, some projects we find there's decommissioning schedules that are planned for 25, 30 years out, where they want the land to even return to the original use as it was before. So they don't even allow any grading. So those are those challenging sites, especially in the particular that they are, because there's grades up to and over even 10% in some of those areas. So it needs definitely a safety product to be able to accommodate those.
And in general, are you agnostic about the the foundation in terms of driven pile versus ground screw?
We do what needs to be done. So the geotech report will typically tell us what needs to be done. We do follow that. We will engineer a solution based on what the findings are at that particular site. We do work with, as far as foundations go, C channel, W sections, driven pile. We can use ground screws, helical screws, things of that nature. So it's all adaptable. Adaptability is an additional thing that we wanted to make sure we had with our tracker.
Sure. Well, let's dive into the tracker. The name of the tracker is what again?
SolX.
SolX, yes.
Yep.
Um,
Yeah, so the Solex tracker, this is not the picture of the Solex tracker that you're showing. It's what is particular is typical out there that we find. Torque tube of sorts. It can be square, it could be D-shaped, it could be hexagonal of sorts, but they're similar principles. As you can see, what you have is there's minimal support along the length of the structure. And what that means is that there's high probability of problems that could arise from dynamic forces or wind forces and with torsional galloping. It does happen with trackers. It's not something that, as we get more and more mature in the market, there are situations that have come up where damage to, arrays have happened on a large scale because of dynamic forces.
sure. Yeah, we're going to show a video here of what you're referring to, torsional galloping.
Mm-hmm.
And was there anything else you wanted to say about the product before we go to that clip?
No, we can go to that clip, and what the clip is showing is basically what happens is, this is kind of a famous example that most have seen if you're in the engineering field. And it was only a 35-mile-per-hour wind that caused this to happen to the bridge. What happened is it hit its natural frequency and it just took over a life of its own. And of course, the bridge collapsed, they rebuilt it, and everything's fine today. But the same thing happens actually with a torque tube type of a scenario. I don't know if you go to the next slide and there's a video there. There goes the bridge. Yeah. And so this is showing here at a consistent rate of speed of wind, and it's illustrating the dynamic or aeroelastic instability of what can happen. And you can see that the forces get more and more extreme as more and more time goes, but yet the wind is going at the same speed. And so that happens. So imagine that on a 50 megawatt site. It could be scary if that happened. It doesn't have to be a huge wind event. It can happen. So many manufacturers, they do to kind of combat that is they add maybe dampeners to their system to help absorb some of those loads, but then that's a high failure point of that. And so what we do is, one of the things that we're different is we do not tube. That's one of the things that we do not. We're a table designed tracker with dual purlins that can mount the module at 2 locations on both sides at the optimal locations that are recommended by the module manufacturer. Mm-hmm. Typically, the manufacturer will recommend a mounting location of about 1,200 meters apart on the module, whereas the typical torque tube mounting is 300 maybe to 600. So that does is it reduces basically the strength of the module itself in wind conditions. It can also, which can cause damage to the module itself. So supporting the product is really the solar, and so that's what we're looking to support. Additionally, so when we do the dual purlin, we also support the length of the row at each location where there's not a dampener, but an actuator that's actually part of the drive system. What that does, that also provides rigidness along to the row to help give support and stability to the array overall.
Are you saying though that there is no torque tube in your tracker?
No torque tube.
Got it. So that's a major difference, is the just the structural design of this Solex Axsus tracker. So the table that we see here is what is then rotated, right? We don't necessarily see the motors. Maybe I can get to
Yeah, that's showing just a portion of it, but what those are, those underneath there, those are actuators. They're basically a screw drive. They're rigid, so they're going to extend and retract, and that's what's going to tilt the module 60 degrees both ways, up to 60 degrees both ways.
Okay, got it. Mm-hmm. Yeah, very interesting. And the net result is that there is less of the module that is hanging over the edge of the bracket, so to speak. In your case, it's a purlin, but on trackers, I think it's called a bracket. That the module is sitting on top of, and those brackets can be surprisingly short, and it makes me wonder, as modules keep getting bigger and bigger.
Yeah.
Are they going to hold up over the 25-year lifespan, the expected lifespan, right? But
yeah. The challenge of the future, I mean, modules are talking about 600, 700 watt modules. Those modules, they're going to weigh 70, 75, maybe 80 pounds. That's heavy for one module. Today, the modules, even they're in the 50 to 65 pound range. Days gone by, they were in the 45 to 50 pound range. So, the modules are getting heavier and heavier. And so, we need to have, something that will give a support to those modules that's rigid.
Yeah, I had Trina on Trina, the module maker, on the show, and next year in North America, or this year in North America, they will have 550 and 600 watt modules coming into the market. I think they're testing some 650s already. And, my question really was, what is the coordination that's going on between module makers to settle on a standardization of the footprint? Because the footprint is they're getting physically bigger. They're almost 4x8. They're 3.5 by 7 feet. These 550 watt modules. They're approaching the size of a sheet of plywood, which is 4x8. And I think that footprint could be a good footprint just from a logistics perspective, because the construction industry is used to dealing with that with dry, with sheetrock and plywood. But it has its hazards across the board. Anything you want to say about this slide before we move on?
Yeah, it's just showing that this, what can happen. It's a rigid design. We can move on to the next slide. That's fine.
Oh, I wanted to point out the little solar. So it's a self-powered system. You have a solar panel.
It can be. Yes. Yeah, it can be. So we can go AC or DC. That's showing you the DC version, where the little solar panel will be, it powers the controller, which powers the motor.
Got it. Is there a battery then affiliated with that system, with the DC system?
Yes.
Yeah.
Yes, there is a battery affiliated with that adds backup for up to, I think it's 3 days.
Nice.
Yep.
Terrain is, always a challenge, no matter what type of racking you're using, of course. Less so for us here in Illinois, although we do run into sites with terrain. And your comments about, all the flat sites getting used up is certainly an issue in the Northeast. And in some states now, they're prohibiting solar on farmland, like in New Jersey, because it's such a small state and such a densely populated state. They want to protect their open spaces, and I appreciate that. Here in Illinois, we're just swimming in farmland, open flat ground. Though we did run into some design issues with subtle rolling terrain. Even very subtle terrain can cause problems, because these rows can be very long. Upwards of, I think, 90 modules with some manufacturers. But
Sure. With terrain, the idea that we wanted to do is reduce the civil work. anytime you do civil work, it can present problems down the line, be it with flooding, if you're near a floodplain, or water runs downhill. So anytime you can reduce civil work, that's a plus. As I mentioned, a lot of folks are even restoring land to their original use after the decommissioning is scheduled for these projects. And so, sometimes that is none. And so what we offer, not just a 10% grade opportunity in one direction, but adulating where it can go up and down because of the independent table design. The tables, and we'll get into it in a little bit, maybe we get to that slide at some point. The tables are connected by a very flexible drive shaft that allows the tables to be connected, even though one may be going at a different pitch and grade than the table next to it. And there you see a picture of an example. New York, back east, far north project with minimal grading done, up to 10% grade, and it's going every which direction, right? So that is something that we can that we're finding more and more common is the need for as we get projects that come into our queue.
Yep. I very much appreciate this. Your table design now. I'm learning more about the system as we go, so that's great.
So, and with the table design too, what it does is we can do tables as few as 6 modules up to 24 modules. So what that enables you to do is to fill in areas that would not be normally filled in with a torque tube. We have, if you hit the button there, it shows that we can do 180 modules in a single row. And so you take an odd shaped piece of property, be it like this, it may be an odd shape. We can typically squeeze more project in, more modules into a project to help you reach your goals regarding your project goals and hitting your target megawatts, as it's shown there. So, dealing with unconventional site layouts helps increase efficiency. And, sometimes that's what makes the project happen.
What is the, what limits your row length to 180? Why is there any row length limit given your design?
Well, the row can be, you have 2 or 3 rows that go in a straight line. When we refer to a row, and I'm referring to a section of the array that is connected by one motor. So that's a 24 volt DC motor that's controlled by one controller.
Okay.
So, and having the longer rows, the longer the rows you can make it, the better, the less controllers, the less motors that you can have. But as far as, you can stack those rows right next to each other if you want to, side by side.
Okay. Got it. When you guys, compare yourselves to the competition, which is all a torque tube design for the most part, as far as I can tell, are there other manufacturers that are not doing torque tubes for trackers?
There's a few. I mean, there's certain advantages that are evident with not using a torque tube, but and so there are a few other manufacturers that do use it, or don't use one, I should say. But the difference is in our drive line and its flexibility and the ability to connect tables together to follow terrain and to do it in a way where it doesn't look like a mess, you might say. So, in fact, if we go maybe to the next couple slides, if we get into maybe the pre-assembly of it, we can kind of get into that. But it's that drive line that's going to make that difference. Obviously, we're compatible with all different types of modules. We customize each job to whatever module that you use. Your job is a job for us. So be it bifacial, first solar modules, 4 or 6, we work with all different types of modules. One of the things we talked about is being compatible with different foundation types. And so the way we designed is basically we design, as it shows there, the driven pile or round post, where we basically attach our T assembly. That's the actuator arm there. We call that our T assembly. We just attach it to an adapter that could be attached to any type of foundation type, including a concrete ballast if need be. There's landfills, things like that. And so where possible, when you think of automotive, you think of pre-assembly. And so we try to design this so that it could be basically installed with local tools that you could, or tools that you could find at your local hardware shop and near the project where you're working at. That can be, wrenches, things of that nature.
But so the module attachment is a clip that's then torqued?
It depends. If it's a bifacial module, we will do an end clamp where it will be clipped on the edge of the module and then torqued. Mm-hmm. If it's a monofacial type of a module, we'll mount them at the holes that are recommended for the manufacturer that are placed there. And the length of the T that you see, we'll separate the purlins, to match up with where those holes are on that particular module. So we design it specifically to be put together like a kit, you might say, like an IKEA kit. It all goes together easily.
And are you? I know how important kitting is. Is that a strength of yours?
We think it is. It's we find that it's less heavy equipment. You think about that you'll need to be able to put these trackers together. Labor is simple. We talk about pre-assembly here. With pre-assembly, we be pre-assembling that T. That can be done on-site or it can be done off-site, depending on what your situation is. If it's done on-site, the nice thing is when you put this T together, you're doing it in an environment that's more like a factory setting. So putting together a factory setting, you're increasing the quality of the workmanship. You're not having your nuts and bolts scattered around the field, around a 40-acre solar site. They're all at one location, so you keep track. You're able to really manage your man hours that way, and of course, the quality is better because the folks that are working on it, workers, they get better at it as they go along doing and putting together the same component over and over again. And that's a lesson we learned from the automotive assembly line. It works well with them, and we wanted to bring that over to the solar industry as well. There, just as an example of, it's an example. You can do it like this, or you can create your own. But with this particular working bench, 6 different workers, we find that you're able to put together about 154 pieces of these T's, this T assembly, in a single day. So that represents about a half a megawatt. And every table will have 2 or 3 T foundation points. So what that equals out to is about a half a megawatt of solar T's and being able to put together a day with six guys. So that's going to reduce your labor costs, but it also makes your costs predictable. Think about it. So and you're not requiring heavy equipment to put these things together.
Yeah, we're big on pre-assembly. If we can, we try to do 15% of our labor in a warehouse setting. Big believers in that.
Yeah, and if you can, some states that they're they require a electrician to, if you're putting it together on site, it requires electrician. Well, off-site installation or pre-assembly can sometimes be done in some areas to help avoid those higher labor fees where these things can be put together by individuals who require lower wages.
Yeah. So the pile that's driven or screwed into the ground is only sticking up a few feet at most, right? And then the
It
T-assembly
depends.
is bolted onto that in the field.
Yeah, it depends. So if it's a C channel, that C channel will typically stick up typically the pile drivers will allow up to 25 inches. If it's a round post of sorts, we'll mount that C channel, and there's not a picture of it, unfortunately, directly to the post on the side. So, that post could be 4 feet high, potentially. But to lower the steel cost, the foundation cost, we wanted to have that foundation be as low as possible when it came to the C channel, because that foundation may need to be thicker, may need to be more heavy duty. And so we didn't want to necessarily carry that all the way up to the top of the racking where it's not necessary. So it's help you can save on foundation and steel costs as well. Sacrificial steel, they call it.
Say that last piece again.
Sacrificial steel.
What do you mean by that?
Well, if you go back to that slide, if you brought that foundation all the way up to the top where it starts to kind of go in.
Yeah.
And, that foundation had to be, let's say 5 millimeters thick or 6 millimeters thick. Then you'd have to make that 5 millimeters or 6 millimeters thick all the way up.
Yeah.
Right. So with that portion, with that extender that you see, it doesn't have to be that thick. I think it's just over 3 millimeters thick. So that extra thickness, when you count, 50 megawatts of pile extensions, that can be a significant cost in steel.
For sure. So here we're looking at the motor and the drive shaft, and tell us about the motors.
So the motor is a 24 volt. It's a DC motor, mounts externally onto a gearbox that mounts onto the actuator there. The drive shaft passes through the motor gearbox and in through the actuator drive shaft. There's only one motor for every 180 modules. So not every actuator is going to have a motor on it, but this is showing you the one with the motor on it. But typically the drive shaft would just simply pass through. It's a square drive shaft. It's about 3/8 of an inch thick. It's very flexible. It's a high quality steel. They've done tests with it up to 40 years through it, and they estimate in our third party test that it would last about 70 years. So that drive shaft is, a lot of people ask about the integrity of the drive shaft, if it's quality or not. That drive shaft is the highest quality steel, and it's very flexible. So that's what enables the tables to be connected and to be driven by the same motor with the changing of terrain, if you think about it.
Yeah.
So what you're showing here, go ahead. Yeah, so what you're showing here is basically the T assembled, and then you see the little grooves cut into the top of the actuator arm there. The type of channel that we use, it's a Z channel. And so what that enables you to do is for you to, with just two folks, I mean, you can do it with two people, to lay that C channel or that Z channel into the groove of the top of that actuator arm, and it makes for easier mounting. So with two or three people, you can mount one of these Z channels onto it, and it's mounted by simple bolts.
Mm-hmm.
And you can see the adjustability there too. the holes those are pre-punched holes.
Yeah.
And so that provides adjustability and tolerances if things are out of tolerance in the field. And of course, that never happens, but we put holes there anyway, just in case.
Oh yeah. The tables, so the table assembly comes together in the field. It's not a pre-assembled item, right?
Right, right. Yeah. So you you pre-assemble the T portion that we talked about. You take that out into the field, you mount it onto the foundation. And once you get 2 or 3 of them up, you have the foundations, the T's assembled for a complete table. Then it's a matter of just mounting the purlins to complete the construction of that particular table.
Yeah.
Then that's what that is what the modules are mounted on top of. You can see the holes that are pre-punched there. So with a standard monofacial module type of scenario, we put those holes at the location and we extend the actuator arm, the length to match up with the holes of where those modules have their holes at the recommended mounting locations. And it's just a bolt with a washer. That's what we have.
Yeah.
And then that's a completed table, 24 modules. So on 24 modules, there's 3 foundation points. And of course, that's showing the DC version. Now you notice the drive shaft there. You can kind of see it if you look really closely. But the drive shafts are about 30 feet length or so. And they're put together by a coupler. And that's pretty simply to put together. So you don't have to worry about the drive shaft lining up with anything in particular. It's a square drive shaft. It'll pass through the gearbox of the actuator, the gearbox or the motor gearbox. And wherever it ends up, basically, within a few exceptions, you just couple another drive shaft next to it. And you just keep running those drive shafts until you hit the end of your technical row, which is up to 180 modules.
And so how high off the ground is the drive shaft?
Yeah, it's about 3 feet, a little over 3 feet above the ground. And that was one of the changes that we made with our new version. As I mentioned, we came out in 2017 with our first version of the tracker. In 2020, we introduced this updated version, and we actually raised the elevation of that drive shaft to help with just keep it out of the area of grass and things of that nature, make maintenance and
I'm thinking sheep.
solar easier.
Grazing sheep on solar arrays is getting more and more popular, and so I don't know what the preferred height is. I did a podcast earlier this week that hasn't posted yet, but they actually are breeding sheep to be shorter to work well under solar arrays.
That's interesting.
Yeah. Is there anything else you wanted to say about the drive shaft?
Yes. So regarding the height that you were talking about, and the short sheep, I guess, one of the things too is agriculture, and they're wanting to be able to sometimes use that land still to grow strawberries or whatever it might be. And they'll ask for the arrays to be significantly higher. So that's something we can do too. So in that scenario, the drive shaft would be significantly taller than the sheep.
Yeah, and this was Minnesota Native Landscapes was on the show. They're saying that they don't see a need to have the array any higher than standard, which is, lower edge of the module, 30 to 40 inches standard here in the Midwest. And the sheep can roll with that just fine. I'm just thinking about them rubbing up against the drive shaft if that's a concern. But I think in this Minnesota case, they're breeding sheep that are shorter than 3 feet, so that shouldn't be a concern. All right. I'm going to get back on screen and um, you know, the uh, the software aspects of trackers are, of course, very important, um, because when you have cloudy or partially cloudy weather, you don't necessarily want the entire array pointing the same direction. Talk a little bit about your software development and tools.
Yeah, so we use P4Q, SunTrack. They are a manufacturer out of Spain, and they've done over about 9 gigawatts of solar overall projects. And they do a great job um, when it comes to backtracking algorithms. We do offer backtracking, and each row can be individually programmed depending on the train and how it's flowing. If it's going north to south or east to west, that does happen. And so some rows may have to receive an adjustment, so we can have each row programmed to follow a certain algorithm. Uh, each each site, depending on, will obviously have uh, wind sensors and things of that nature, because wind is everywhere, obviously. But depending on the location, it may also have snow sensing levels. So the wind, we stow at 0 degrees where we're at. Uh, that's our typical stowing, and it'll stay in operation through about 30 miles per hour wind or so. We can design the system to withhold. The standard design actually has a wind resistance of about 150 miles per hour in the standard design. So, if you're in an area that has fierce winds, I think the limiting factor would probably be actually what we would be able to do is the module itself, but it could handle. So we would be able to build a racking system that would be able to support up to whatever you need. So because everything is customized, like I say. So, but with the wind, we mentioned that. But with the snow, how it works is basically a laser will measure where the snow is, where the snow falls on a platform of sorts, and once it senses 3 inches of snow, it kicks in, and that tracker will rotate 60 degrees one way. Oh yeah, there you go. It'll rotate 60 degrees one way, and it'll dump the snow. And then the next time it senses the next 3 inches, it rotates the opposite way, and it'll dump the snow. Mm-hmm. And so you're not having the snow build up just on one side of the tracker. Those are interesting pictures, because that's showing our tracker in action. I like those pictures a lot.
Is that a different version? Because it looks like a slightly different.
Yeah, that was our original, one of our original designs. Uh-huh. That happens to be the table where the motor was mounted, but that's one of the things we eliminated. You can see the motor is actually mounted directly onto the pile itself, whereas the older versions, the motor, it had a special. It was mounted on some additional bracketry between the piles. So it was one of the improvements that we made.
The lack of dampeners. Tell us about that. That's a very common thing when you have a torque tube. Is that because you're a table design that you don't need the dampener?
Well, yeah. I mean, every foundation point will have a drive line. It will have a screw drive, basically, that will give support to the array. Mm-hmm. So a dampener is not needed in that.
It would be redundant. Yeah.
Yeah. So it's rigid. It moves all together, and dampener is not needed.
Got it. And refresh my memory, UL 2703 and 3703, what are those referring to?
Well, electrical and UL certifications for trackers. So we do have that, and for each, as modules come out, we do go submit for approval for the 2703, which it's pretty easy to, it's just basically grounding. So it's pretty easy to get those as new modules come out. So we do have those.
Yep. All right. Let's talk about the traction that you're getting in the U.S. market a little more. I mean, you're a newcomer in the tracker world. You said 2017, right?
Yes, 2017.
Yeah. And developers and installers certainly do not change products easily. They find products that they like and they use them repeatedly if possible. One of the openings is when, like we had this year in Illinois, there was so much Array Technologies, for example, that was going in, that one of the developers that we did some community solar with moved to a different manufacturer because they were nervous about supply chain and labor related issues with Array. Array has captured a ginormous part of the community solar. I estimate 80% of the community solar in Illinois. And but what is your strategy, and what are your successes?
Yeah, so I mean that's one of the benefits of working, with Axsus. When we start talking about supply chains and things of that nature, as an affiliate of Axsus or a company of Axsus, we have the ability to leverage the experience, the working relationships, the supply chain, the logistics, that Magna has built over the decades to be able to meet, the requirements of any given job. And Magna is a $40 billion a year company. You work with Magna and Axsus, as far as bankability for products, that's something that is something that a customer can have full confidence in because of the size of our company. And you think about things like warranties, things of that nature. Magna's been around since 1957, and yes, Axsus has been around since 2008. But we are, supported by Axsus or by Magna. And so when you think about a warranty from a company that's been around for a couple of years, how valid is that if they've only been around for a couple of years? Well, because we're, affiliated with Magna, a customer can have confidence that, we're going to be there because of the longevity of the company that we've had. And so in making, headway with, in the market, I think it's people do see that we have those advantages. And then with the design features that we have, how do we get introduced? Well, it's there are companies that are interested in exploring new technologies per se, because the market is becoming more difficult when it comes to land uses and things of that nature. And usually, the easy introduction to somebody is when somebody has a problem, and they have a site that has a problem, and that site problem is usually terrain, or they're not able to meet their target megawatt on a particular site. And so we share with them this presentation or have something similar, and they say, hey, I think maybe you can help us out. And then we go through a vetting process at that point in time. Once you go through the vetting, they go through the vetting process with us, I should say, where they're vetting us, and you start seeing, who we are as a company and the size of the company we are. It's easy to for them to see that we're easy to work with. We're bankable, and we're going to be able to meet the demands of their project.
And you've also been through some rigorous bankability testing with is it with PVEL, or who did you do you did some testing with one of the international labs, right?
Yeah, we've done Leidos is one. We've done some testing with DNVGL, among other companies. And as sometimes as we get vetted by, or we're being vetted by another company, they have their own independent engineer of sorts, so they want to take a closer look at us. So we've gone through it a few times, and once, like I said, once you get into it, and you see the testing that we've done. I mean, an automotive manufacturer, that's one of the things that they do well. We do our own testing. Well, I should say we hire third-party engineers to do testing for us, and then we take their results and then we revalidate them ourselves. So that we'll have them, for example, do testing on the motor, and then once we get those results back, we'll test it the way we know it's going to run, on site. And then we'll be able to figure, with confidence say, this product, once it goes out on the market, this is how it's going to perform. That's what an automotive manufacturer does. They test the door of the SUV and they open it and they close it. It's all it does all day, and it opens and closes it 10,000 times until it wears out. And they say, okay, this door will last so long. Well, we do that with the components of the tracker. And so when we put it to market, we know what it will do, and so you can have confidence so that there's no surprises. And a lot of the larger companies have done that as well. A lot of the smaller companies that are newer out in the market, similar, they don't have those resources that we have, and so that is one of our advantages.
Great. Well, how can our listeners reach you, Ryan? I'm going to put your map of projects on the screen here also, but what's the best way for people to reach out to you?
Best way to reach out is you can email me at ryan.kiarsis@magna.com. It's ryan.kiarsis, KIARSIS @magna.com, or call me. That's an easy way too. 602-536-6610. 602-536-6610.
And you've clearly been holding out on me because you have some projects in Illinois, it looks like.
We do.
And would love to visit a site or two. So let's work on that. I want to make a couple of announcements. And as our listeners know, I do 2 of the Solar Podcast interviews every week. You can find all of our content at cesnrg.com/videos. Here you see we interviewed Jigar Shah again just last week, and we're talking about the $1 trillion wealth creation opportunity under the Biden administration for clean energy and the clean energy transition. So check that out. DC coupled storage, that's a second episode. We're covering some of the technicalities of DC coupled storage with a manufacturer called Alencon out of Pennsylvania. Just wonderful, super smart guy, Hanan Fishman. Check him out. We did an episode on the Nextracker Gemini with a wonderful contractor named Sunshine Solar and their CEO, Emily O'Leary. They're from Georgia, but we visited a project. It's a community solar garden up in northern Illinois, far northern Illinois, where the Gemini 2 in Portrait tracker has been installed. And as you and I were talking, Ryan, in the pre-show, 2 in Portrait is definitely a thing. And it sounds like you guys are going to be rolling out a 2 in Portrait design yourselves.
We will be, yes. That should happen this year, actually, so stay tuned.
Awesome. Well, give us a thumbs up, folks. We really appreciate your listening and your support. Subscribe to our YouTube channel, please, if you appreciate the content, and share it with your friends. That's the way that people find out about what's going on in the solar industry. This is a rocket ship for the next 15 to 50 years. We're going to be adding 800 gigawatts of solar in the US. And so it is a huge economic opportunity for the entire value chain, from manufacturing to installers, engineers, salespeople, marketing professionals, electricians, mechanical installers. We need all kinds of trades and all kinds of talent to get into solar. So please share the content with your colleagues so that more people can learn about what's going on. I want to thank my guest, Ryan Kiarsis with Axsus Solar, a Magna company, for joining us today on the Solar Podcast. Thank you very much,
Thank
Ryan.
you. It was a pleasure. I enjoyed it very much.
Let's grow solar and storage. I'm Tim Montague, your host. Take care.